Alright, so this video we're going to look at right triangle trigonometry. We'll solve some right triangles. We will do some applications, some word problems. We'll look at angle of elevation, angle of depression, that kind of stuff. So this example here, it says find the angle alpha that satisfies each equation where alpha is between 0 and 90 degrees. So our angle is between 0 and 90 degrees. Now, if you've been watching these videos, in the last video or the last couple of videos, we've done some problems like this right here, where we drew like a 45, 45, 90 triangle, 30, 60, 90 triangle, and we did all that kind of stuff, and we had angles on the quadrants at 0, 90, 180, and 270, and we worked it all out. You're not gonna evaluate these things like that. Okay, that was just to kind of show you what's going on, so you could see it in detail. The thing with this is you've got to memorize this stuff. Okay, I know I've said, if you've watched my other videos in this playlist, you've heard me say it over and over. You've got to memorize the sine, cosine, and tangent of 0, 30, 45, 60, 90, 180, 270, and 360 degrees. You've got to memorize those. Okay, so what I'm going to do right now, I'm going to write those down so you'll have them. So we've got the sine of 30 degrees is 1/2. The sine of 60 degrees, square root of 3 over 2. Sine of 45 is square root of 2 over 2. And then we got cosine. And, I would write these down as I'm writing them down. Cosine of 60 is 1/2. Cosine 45 is square root of 2 over 2. And then we got tangent 30, that's square root of 3 over 3. Tangent 60 is square root of 3. And tangent 45 is 1. Okay, so that's those values there. And then we also need the sine of 0 degrees, the sine of 90, the sine of 180, and the sine of 270. You need to memorize all these. That's 0. This is, let's see, that's 1, 0, and then the sine of 270 would be -1. Okay, so just make sure that you memorize those. Okay, now later on in videos, when we get to the graphing these things, I'll show you a way to memorize these a little bit easier. But then we have to do the same thing: cosine 0, cosine 90, cosine 180, and cosine 270. All right, so the cosine of 0 is 1, 0, -1, and then cosine of 270 would be 0. All right. Now, I know I don't have 360 degrees. The sine, cosine, and tangent of 360. That's going to be the same thing as sine, cosine, and tangent of 0. Okay, those would be the same thing. And then we've got tangent 0, tangent 90, tangent 180, and tangent 270. All right. So, I mean, you can get these pretty easy because you know tangent is just sine over cosine. This would be 0. This is undefined. This is 0. And this is undefined. All right. So all of those, you've got to memorize them. So if we look at this, we've got sine alpha equals square root of 3 over 2, and we need to know what alpha is. All right, so what can I take the sine of to get square root of 3 over 2? Well, if you've got this memorized, you can see the sine of 60 is square root of 3 over 2. So that's going to give us alpha is equal to 60 degrees. And then what about the cosine of what gives us 1? Well, see here the cosine of 0 degrees. So that's alpha equals, I'll write it there. So we get alpha equals 0 degrees. And then tangent alpha equals 1. So what can I take the tangent of to get 1? Well, that's the 45 degrees. So alpha equals 45 degrees. And so that's those values there. So you can see, memorizing all of this right here, it makes it so much easier for you to work these problems. And I'm telling you, if you don't memorize this right here, you're going to really struggle in trig. All right, so now we've got definition of inverse, sine, cosine, and tangent functions. So we got the inverse sine of x equals alpha, provided that the sine of alpha equals x, where alpha is between negative 90 and 90 degrees. And then same thing for cosine alpha, but alpha is between 0 and 80. And then same thing for tangent, where alpha is between negative 90 and 90. Now, notice this part over here. Now, that's important, and we don't go into a lot of detail in this part of the trig class on this stuff right here. That right there, when we get to the inverse trig functions, we'll get more in depth on this stuff right here. But notice here that alpha, notice it's less than or equal to, less than or equal to. Notice that or equal to, because it can equal negative 90 or 90 degrees. But over here on tangent, notice there's no or equal to on the inequality symbols. That's because tangent is undefined at negative 90 and 90 degrees. And you saw that up here. See, tangent 90 is undefined. And then for cosine, alpha is between 0 and 180 degrees. And it can equal 0 and it can equal 180 degrees. So if we look at this, evaluate each expression, we're taking the inverse cosine, the inverse sine, and the inverse tangent. So the way that you think about this is similar to it's like what we did up here. Okay, it just wasn't written like this. I mean, you could write this as alpha equals the inverse sine of square root of 3 over 2. Okay. This right here, this part right here that I've written, that goes to this. Okay, so all you're doing here is you're asking yourself, what can I take the cosine of to get square root of 2 over 2? Well, we know here this is 45 degrees, this is 60 degrees, and this is 60 degrees. Okay. And that goes back up to this right here, what I've written here. See, look, square root of 2 over 2 for cosine. See, cosine, square root of 2 over 2, that's 45 degrees. And then the other one was, I think, sine, let's see, yes, sine, inverse sine of square root of 3 over 2. Well, look at this. There's square root of 3 over 2, the sine of 60 degrees. And then the other one was inverse tangent of square root of 3. Well, if we go back up here, see square root of 3, the tangent of 60 is the square root of 3. That's all you're doing there. Okay, so like I said, memorize that up there. You've got to know that. All right, now for this one, we are evaluating these, and these aren't one of the special angles. It's not one of these up here. Okay, this right here is something you would do in your calculator. Okay, so you have to evaluate this in your calculator. Now, for the most part, calculators, they're going to do the same thing. You'll do the same thing on just about all calculators when you evaluate the inverse trig functions. On your calculator, there is a button. And let's just look at sine. There's a sine button. And then above the sine button is this inverse sine. And then you also have a button on your calculator. On mine, it's kind of blue, and it's this second. So to get to the inverse trig functions, you have to hit your second button and then hit sine, and then on the display, it'll pop up this inverse sine. Okay? And so you just do that with all of these. So you would hit second, and then in this case, cosine, and then type in -3 divided by 7 and hit equals. And that should give you 115.4 degrees. And then the same thing, hit your second button, sine, and that'll give you your inverse sine. And then type this number in, and that will give you 13.6 degrees. And then here, hit second, and then your tangent button, and that should give you inverse tangent, and then type in the 6.1, and that'll give you 80.7 degrees. All right, so now let's look at this when we have a right triangle. All right, so we have, if alpha is an acute angle of a right triangle, so here's alpha, okay, and here's your right angle, then sine alpha is O over H. This is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then as far as the cosecant, secant, and cotangent, well, if you know sine, cosine, and tangent, you can get these really easy. See, you just flip them. They're just the reciprocals. Remember that? Cosecant is the reciprocal of sine, and so on. Now, I know in an earlier video we learned that sine was y over r, cosine x over r, and tangent y over x. It's good to know it that way. And you know, if you're given a point coordinate xy, okay, you can use the y over r, x over r, y over x. But if you're not, if you're not given the point coordinates, then you can use this opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So if we look at this, we have our angle alpha here. So this would be the side opposite. This is the side adjacent. And then remember, the hypotenuse, that's always opposite the right angle. Okay, that's the side that's opposite the right angle, the hypotenuse is. All right, so let's look at an example using this. It says, find the values of all 6 trigonometric functions for the angle alpha of the right triangle with legs of length 1 and 4 as shown in the figure. So we have our triangle here. So here's alpha, so this is the side opposite, this is the side adjacent, and then here's your 90-degree angle, so the side opposite that's your hypotenuse. So what we're going to do here before we can solve anything, well, we've got to know the length of the hypotenuse. Well, that's just the Pythagorean theorem, okay? So we know the hypotenuse squared, which we'll call that, let's just call it C, is equal to, the other two sides squared and add them together. So this is going to give us C is equal to the square root of 16 plus 1. So I did 4 squared is 16, 1 squared is 1, and I took the square root of both sides. So C is equal to the square root of 17. So this is the square root of 17. All right. So we want to find all 6 trig functions. All right. So let's find sine alpha. So sine alpha, remember sine is opposite, which is 1, over adjacent, which is square root of 17. Okay. Now we know that we don't leave our answer like this, do we? We don't leave our answer like this. We've got to rationalize the denominator. So to rationalize the denominator, I'll show how to do it on this one, and then I won't show it after this one. So this is just square root of 17 over 17. Okay, so there's sine alpha. Now let's find cosine alpha. Well, cosine alpha is adjacent over hypotenuse. So that's 4 over the square root of 17. And then we'll rationalize denominator, multiply numerator and denominator by square root of 17. That's 4 square roots of 17 over 17. Right? And then we have tangent alpha. Well, tangent is what? Opposite over adjacent. So that's 1/4. All right. All right, so we found sine, cosine, and tangent. So remember, I told you, all you really need to do is remember sine, cosine, and tangent. Then the other ones we can get pretty easy. So cosecant alpha, well, cosecant is the reciprocal of sine. So be smart about this. Think about it for just a second. We got this to be sine alpha. But if I take the reciprocal of that, I get this. And then if I rationalize denominator, I get 17 square root of 17 over 17. The 17's cancel, and I'm left with the square root of 17. You can do that, that's fine, but you're putting more work on yourself. Okay? And what I mean when I say be smart about it, we've got sine alpha is equal to this. That's right. But sine alpha is 1 over square root of 17. 1 over square root of 17 and square root of 17 over 17 is the same thing. Okay? This is just the denominator is rationalized. Here, the denominator is not rationalized, but they're the same thing. If you punch this into your calculator, 1 over square root of 17, and then you punch square root of 17 over 17 in your calculator, you'll get the same answer. They're the same thing. So why not just take the reciprocal of this one? So what's the reciprocal of 1 over square root of 17? Just square root of 17. So you're done. You don't have to rationalize the denominator. And then we can do the same thing for secant. I'm not going to flip this one because this is the same thing. I'm going to take the reciprocal of this. So that's just what? Square root of 17 over 4. Okay. And then we've got cotangent. Whoop. And then we've got cotangent alpha. So the reciprocal of 1/4 is 4. And there's all 6 trig functions. Okay. All right. Let's look at the next example. All right, solve the right triangle in which alpha equals 30 degrees and C equals 6. All right, so this it might be kind of confusing here. You know, they don't give you a triangle, so how do we label it? Well, if you look at this, let's just draw a right triangle and label it. There's your right triangle. We're going to call this C. Well, I'm sorry. Let's call this right angle, call that gamma. Let's call this alpha and call this angle beta. And we will say that side opposite alpha is side A, the side opposite beta is side B, and the side opposite gamma is side C. Now, if they just give you, you know, the lengths of a side or something, C, you're going to always label C as the side opposite the hypotenuse. Okay? Label the hypotenuse C unless they tell you differently. Okay? But that's pretty typical across all the trig books. Okay? And as far as labeling the angles, sometimes you might see the angles labeled A, capital B, and capital C. Okay? The book that I'm using, it uses alpha, beta, and gamma. We'll use gamma for the 90 degree, and that's typically what you do. The right angle is typically labeled gamma. Now, as far as alpha and beta, it doesn't matter if you label this angle alpha and this angle beta. That doesn't matter. But if you do that, if you decide to label this alpha and this beta, which that's fine, just make sure you label that side A and that side B. But this one's going to always be gamma and C, unless they tell you differently. Okay? All right. So now we know how to label the triangle. So as far as, working these, what I like to do is you can make a table, angles, sides. All right, so we've got alpha, we've got beta, we've got gamma, we got side A, side B, and side C. So here we know this is 30 degrees. We know this is 90 degrees because it's the right angle. A, we don't know what A is. We don't know what beta is. We don't know what side B is, but we know side C has length 6. Okay, so all I've done is I've made up a table. I've created a table, and now I know exactly what I need to find. And the other thing about this, it makes it easier for your teacher to grade it too, I think, instead of having everything scattered all over the place. Okay, makes them happier, and it might make them go a little easier on grading your paper if you make it easier for them to grade. All right, so let's look at this. Let's go ahead and find beta. Okay, let's find beta. So beta, well, I know that all the angles of a triangle add up to 180, right? Well, if this side here, this gamma, that's 90, that means beta and alpha add up to what? 90. See, 90, and then if you add this angle, and let's go ahead and label this 30 degrees, and then let's label this 6. So 30 plus what is going to give us 90, and then plus this 90 is 180. So beta is 90 minus 30, which is 60 degrees. So that's 60 degrees. Okay. All right. Now let's look for side A. Okay. Let's calculate A. So I've got alpha is 30 degrees, and I'm looking for the side opposite that angle, right? See, A is opposite angle 30, is opposite alpha, and I know the hypotenuse. Well, what do we know about opposite hypotenuse? Well, that's what? Sine of 30 is opposite over hypotenuse. So if I solve this, this is going to give me, let's go this way with it. A is equal to what? 6 times the sine of 30 degrees, right? See, if I multiply by 6, the 6 cancels, it comes up here. And so I'm going to get A is equal to 6 times, and then what's the sine of 30 degrees? Well, that's 1/2, so this is 3. So I get 3 here. Now, we need to find beta. Okay, we need to find the length of beta. Now, I could use Pythagorean Theorem. Okay, I could do that. Or I could use the fact that I know alpha is 30 degrees. This is the side adjacent and the hypotenuse. So we know cosine of 30 degrees is adjacent over hypotenuse. Okay, and this is a B right here. All right. So this is going to give me what? B is equal to 6 times cosine 30 degrees. And so I get B is equal to 6 times square root of 3 over 2. Cosine of 30 is square root of 3 over 2. So that's going to be 3 square roots of 3. So that's 3 square root of 3. Now, you might be thinking, well, could I have used, because we found beta, right? We found that was 60 degrees. Could I have used that? And if I would have used beta, I've got what? Opposite and hypotenuse, right? You see that? Opposite and hypotenuse. Well, let's look at that. So opposite and hypotenuse, what's that? That's the sine of 60 degrees is what? Opposite over hypotenuse. So B is what? 6 times the sine of 60 degrees. So B is what? 6 times, and the sine of 60 is square root of 3 over 2, which is 3 square roots of 3. So you get the same answer. So you can see there's more than one way, there's more than one paths you can take to get the correct answers. And if I would have used the Pythagorean theorem, that would have worked also. But this is what I always tell my students. While this right here, this is perfectly fine, why did I choose to do cosine? Because if we look at this, notice in this problem when I set it up, this value and this value were given. See, that was given to me in the problem. Now, when I look at this one, this value was given, but this value here I calculated. What if I would have calculated this wrong? What if I would have made an error? Well, then that means this answer would have been wrong also. Okay, so what I tell my students, use the given information. Okay, anytime you're calculating this stuff, always use the given information. Now, there's going to be times that you can't use the given information. You'll have to use some information that you calculated. Okay, I know that. But if all possible, use as much given information as you can. And in this case, to solve for side B here, we could use all given information. Okay, and so this right here is your final answer. And see how nice that looks? It's all organized. You can get your answers quick. All right, so let's look at this one. Okay, we're going to do the same thing. Solve the right triangle where A is 4 and B is 6. Find the acute angles to the nearest tenth of a degree. Okay, so they're telling us, we may not get nice angle measures here. Might have to use our calculator, round your measures to round your angle measures to 1 decimal place. All right, so let's look at this. So let's draw this. Let's label alpha, beta, gamma, A, B, and C. Okay, well, they tell us that A is equal to 4 and B is equal to 6. And let's go ahead and draw this. I've got beta, gamma, we know that's 90, that's our right angle. A is 4, B is 6, and we need to find C. All right. So let's see what we can do here. Well, I guess we can go ahead and find the length of C. Okay. So I know C squared is equal to A squared plus B squared. So C squared is 4 squared plus 6 squared. So C squared is, what is that? That's 16 plus 36. Yeah, 16 plus 36, that gives us 52. So C is the square root of 52. So C, that would be what? 2 square roots of 13. Because remember, 52 is the same thing as 4 times 13. Square root of 4 is 2. Okay, so there's C. That is 2 square roots of, 2 square roots of 13. Now notice they didn't say to round the side, the lengths of the sides. They didn't say to round that. They said just round the angle measures. So we'll leave that as an exact answer. All right, so now we need to find alpha and beta. So how about we find alpha? So I need to find the angle measure for alpha. Let's see, look at this. What do we know? We know opposite, we know adjacent, and actually we know hypotenuse too. But remember, we calculated hypotenuse. Let's use all the given information. So I know that sine alpha is equal to what? Opposite over hypotenuse. You see that? I'm sorry, opposite over adjacent. I had a little moment there, didn't I? How about tangent alpha is equal to opposite over adjacent? Does that sound a little better there? Okay. So this tells me that alpha is the inverse tangent of 2/3. Okay, so second tan 2 divided by 3, that is 33.7 degrees. So that's 33.7 degrees. 33.7 degrees. All right. Honestly, where sine came from, I have no, I don't know why I used that. I guess I was talking about hypotenuse, and I had hypotenuse in my mind, so I wrote sine as opposite over hypotenuse. But anyway, but look, if you wanted to do that, sine alpha is equal to 4 over 2 square root of 13. You could do that, okay, and you would get the same answer. But remember what I said. This 2 square root of 13 was calculated. Use the given information if you can. And so beta, we can find beta. Well, we know alpha and beta have to add up to 90 degrees. See, these two have to add up to 90 degrees because 90 plus this 90 here for gamma is 180. So that's going to be 90 minus 33.7 degrees. And so I get beta is 56.3 degrees. Yep. And so now here is my answer. All right, so the main thing is just draw your triangle out. Okay, draw the triangle out and label it, and then if you want to make that table, I think it makes it easier. All right, so here's the fun stuff, getting to the word problems. I think we got 3 problems left to work. So we've got angle of elevation and angle of depression. Remember, angle of elevation and angle of depression is measured off the horizontal. Okay, it's measured off this is your horizontal line. Here, this is your horizontal line. Students are pretty good about getting the angle of elevation. It's the angle of depression that they mess up. But the angle of elevation, see, here's your horizontal, so, you know, and here's your angle of elevation right here, measuring off the horizontal. Here's your horizontal, the angle of depression, that's this. Okay, that's your angle of depression. So let's look at some problems here. So it says a guy wire of length 108 meters runs from the top of an antenna to the ground. If the angle of elevation of the top of the antenna sighting along the guy wire is 42.3 degrees, then what is the height of the antenna? Okay, so let's draw this. So we've got an antenna here, and we've got a point out here on the ground looking up to the top of the antenna. Okay, so it tells us the angle of elevation is 42.3 degrees. So that's measured here. That's your 42.3 degrees. That's your angle of elevation measured off the horizontal. And it tells us the length of the guy wire is 108 meters. Okay, and they want to know what is the height of the antenna. So we'll label this H, and that's a right angle there. All right, and then that's assuming the tower is built straight up and down. Okay, all right, so we need to know this height here. So let's see what we've got. We've got the angle. The side we're looking for is opposite that angle, and we know the hypotenuse. So opposite hypotenuse, that is what? That sine of 42.3 degrees is opposite over hypotenuse. All right. And so if we solve for H is equal to 108 times sine 42.3 degrees. And so we get the height is 72.7 meters. And you would just punch this into your calculator. 108 times sine 42.3 degrees. All right. Here we've got another angle of elevation. Then the last problem is an angle of depression. All right, so the angle of elevation of the top of a water tower from point A on the ground is 19.9 degrees. From point B, which is 50 feet closer to the tower, the angle of elevation is 21.8 degrees. What is the height of the tower? All right, so let's draw this up. So we've got a tower here, and we got a point out here that's going up to the top of the tower, and they tell us that is 19.9 degrees. Okay, and you know, you can call this point A. All right. Now they tell us that we have a point B, which is 50 feet closer. That's point B. And they tell us the angle of elevation here is 21.8 degrees. And this is a right angle. And they want to know what is the height of the tower. All right. So how in the world are we going to do this? All right. So what we'll do first is we'll just call this. Let me redo that. We'll call this length X because we don't know how far this point B is. Okay, so we just call it X. But we do know that the distance between A and B is 50 feet. Okay, so how are we going to do this? Well, if you look at this, do you see two right triangles here? We have this right triangle here. Okay, and then we have this bigger right triangle right here. Okay, so I can, if I look at this smaller right triangle that includes, from point B goes up and back down. Well, this angle here, I've got opposite and adjacent, right? H is opposite the angle, X is adjacent the angle. So that's going to tell me that tangent of 21.8 degrees is equal to opposite over adjacent, right? And then if I look at the bigger triangle, well, I know this is X plus 50 feet, right? See the 50 plus the X. Well, I've got opposite. The side opposite is H. See, I'm looking at the big right triangle now. The side opposite is H. The side adjacent is X plus 50. So that tells me tangent of 19.9 degrees is equal to opposite over adjacent. All right, so look what we've done here. We've got what? We've got H is equal to X times tangent 21.8 degrees. And here we've got H is equal to X plus 50 times tangent of 19.9 degrees. So what I did is I took each one of these equations and I solved for H. Well, what good did that do? Well, this H and this H, they're the same, right? So that means X times tangent 21.8 has to equal X plus 50 times tangent 19.9. And now I just solve for X. So I get X times tangent 21.8 is equal to X times tangent of 19.9 plus 50 times tangent 19.9. And so I'm going to move this term over here. So X tangent 21.8 degrees minus X tangent 19.9 degrees is equal to 50 times tangent 19.9 degrees. And then look, I can factor out of X. That's tangent 21.8 degrees minus tangent 19.9 degrees equals 50 times tangent 19.9 degrees. And then what do? See, this is just algebra now, solving an equation. Then I divide both sides by this. So I get X is equal to 50 times tangent 19.9 degrees over tangent 21.8 degrees minus tangent 19.9 degrees. And you can punch this into your calculator and you'll get a value for X, and then you can either plug it back into this X or you can plug it into this X. Doesn't matter. And then you just do whatever you got here times tangent 21.8, and that'll give you your answer. Okay, but I think what I'm going to do here is I'm just going to plug this whole thing in for X into this one. So I'm going to get H is equal to, let's write this down, X times tangent of 21.8 degrees. So that's going to be X, which is this. That's 50 times tangent 19.9 degrees over tangent 21.8 degrees minus tangent 19.9 degrees. Okay, so that, and then times tangent 21.8 degrees. And then once you put all that into your calculator, assuming you put it in there right, you get 190.6278641. I'm just going to say it's 191 feet. And there's your answer. Okay, so that one's a little tougher. There's a little more work you got to do with that one. All right, so now for the best news of the day, this is the last problem. So from a highway overpass, 14.3 meters above the road. The angle of depression of an oncoming car is measured at 18.3 degrees. How far is the car from a point on the highway directly below the overpass? All right, so let's suppose you're standing up here on an overpass, and that overpass is 14.3 meters above the ground. All right, and then there's a car coming. There's a car down here that's coming, and you're looking at the car. See if I can draw that a little straighter. Okay, there's a car coming. And how far is the car from a point on the highway directly below the overpass? So they want to know that distance there. That's what they're looking for. All right. Now, what do they give us? They give us the angle of depression is 18.3 degrees. Now, this is where students mess up all the time. That angle of depression of 18.3 degrees, what most students do is label that 18.3 degrees. That is not the angle of depression. Remember what I told you up here. The angle of depression is measured off the horizontal. So if we look at this, so let's erase this. All right, so if we draw in our horizontal here, this is your angle of depression. See that? Now, this angle, well, this is a right angle here, right? So this angle is 90 minus 18.3 degrees. So 90 minus 18.3 is 71.7 degrees. So this is 71.7 degrees. All right. So now, and of course that's a right angle. So now let's find x. Well, I know this angle, right? Well, this is the side opposite. This is the side adjacent. So I know tangent of 71.7 degrees is opposite over adjacent. And so x is equal to 14.3 times tangent 71.7 degrees. And that is going to give me 14.3 times tangent of 71.7. And that is x is equal to 43.2. And what is it? That's meters. All right. So, hope that video helped. Like I said, that's some application problems, solving right triangles. But this right here, this is what you have got to memorize that. You've got to know that. Okay? So, hope the video helped. Check out my other videos. Give me a like, share, and subscribe. See you later.